Right, in this video then we're going to be looking at domain and range and some key functions which will occur frequently throughout the topic. Just to recap, the domain is the set of possible input values and we can represent it on a mapping diagram like the one shown. It's often useful to consider the different types of input that the function can take. So, can the function take positive values? Can it take negative values? Often it's worth considering if the function can take 0. Now these aren't the only ways of approaching it, but it is quite a helpful starting point. So let's start by looking at a few common functions that you'll encounter and how we can approach finding what's called the greatest possible domain for each of these functions. So the greatest possible domain just means what is the largest possible set of values that we could put into this function. In this example, we have f of x equals root x. Thinking about which values we can put into a square root, you should notice that we can't square root negative numbers. And that means the only values we are allowed to put into the function are positive numbers or 0. So our greatest possible domain is x is greater than or equal to 0. In each of these examples, I'm also going to say x is a real number. But in the exam, strictly speaking, it's not necessary to write that on the end. Now, when we're working with domain and range, it's often useful to think about the shapes of the graph. So in this case, here's the shape of y equals root x. Notice that in the x direction, we haven't got any values less than 0. And also, the curve would continue off towards x's positive infinity. So by either knowing the shapes of the graphs or plotting them on a graphical calculator, you can confirm whether your answer makes sense. We could also find information about the range by considering the possible y values, but that's something we're going to come to later. In the next example, we've got f of x equals e to the x. Once again, we'll consider the types of number that we're allowed to put in. Are we allowed to put positive numbers in? Can we do e to the 5? Yes. Can we put 0 in? E to the 0 is 1, so yes. And can we put negative numbers in? Well, yes, we can put negative numbers in because e to the minus x is equal to 1 over e to the x. So this means we can put any value that we like into this function. So the greatest possible domain is x is any real number. Let's make links with the shape of the graph. Notice that the graph extends off in the positive direction to infinity, and it also extends off in the negative direction to infinity, which confirms our answer that we can put any value we want into it. Next, we'll look at f of x equals log x. Now I've got base a here, but this will apply to any base that you want. The rules will still be the same. Let's have a think about the types of number we can put into logs. Can we put positive numbers into logs? Yes. Can we do a log of 0? No, that's undefined. And can we do the log of a negative number? No, that's also undefined. So the only thing we can put into a log is a positive value. That means we can say the greatest possible domain is x is bigger than 0. Notice here that it's a strict inequality. X has to be bigger than 0, it can't be equal to 0. Making links with the shape of the graph, notice that the graph of log x only exists for positive values of x. And also notice that at the far end of the graph here, it goes off to infinity for positive values of x. Next, we have f of x equals 2x plus 1 over 3x plus 4. To work out the greatest possible domain, we want to think, is there any value that we can put into this function that will mean that it's undefined? With a fraction in particular, we need to remember that we cannot divide by 0. So the question we need to answer is, what value would make the bottom of the fraction 0? If you can't immediately spot it, the equation that we could solve is 3x plus 4 equals 0, which gives us 3x equals minus 4, x equals minus 4/3. So in this question, the only value that we can't put into that function is x is minus 4/3. So the greatest possible domain is x is not equal to minus 4/3. I'm not going to draw the graph of this function just yet because I think it'll be really helpful to discuss that in more detail when we talk about the range of this function. Okay, here are a few quickfire questions then to test your understanding of the domain of a function. The first 4 are fairly straightforward. The last one with tan x is an extension question though, so don't worry too much if you don't get the answer to that correct, but it is still worth having a think about. Pause the video, have a go at the questions, and then come back and check your answers against mine. Okay, welcome back. Here are some answers then. So for the first one where we've got a square root, the inside of the square root cannot be negative, and so we want x is bigger than or equal to minus 5 over 2. For the next one, the log has to be positive, so we want x is bigger than 1/3. For the third one, f of x is sine x. Sine can take any real number, so we get x is in R. For the next one, f of x is 3 over x plus 5. We can't divide by 0, so x is not equal to minus 5. And for f of x equals tan x, the extension question then, if you think about the graph of tan x, you'll notice there's an asymptote at 90 degrees. That means we need to have x is not equal to 90. However, there are further asymptotes every 180 degrees after that. So if we did 90 plus 180, that would get us another asymptote, and then plus 2 lots of 180, that's another asymptote. So we can add on 180n, where n is an integer, so any whole number. If you wanted an answer for this in radians, the answer would be x is not equal to pi over 2 plus n pi. Don't worry if you didn't get that last one though, it's beyond the scope of the course, it's not something you'd be tested on. Right, now we're going to look at the range of some functions then. So just a reminder, the range is the possible set of output values. The way we go about finding the set of possible values in the range is similar in many ways to the domain, but it's often more important to think about sketching the graph. We are still going to be interested though in the types of possible output. So are positive outputs possible? Are negative outputs possible? And is 0 a possible output? So let's have a look at the range of the same functions we were examining before. First one, f of x equals root x. We'll sketch the graph to start with. And by looking at the graph, we can see that the output values, or the y values, are all greater than or equal to 0. You cannot get a negative real number out as the answer when you square root something. The other thing to notice about this curve though is that as the x values get bigger, the y values keep increasing as well, and so f of x approaches infinity. So we can say the range of the function is f of x is bigger than or equal to 0. A crucial point here that often trips people up in the exam is when we're writing down a range, we don't just use x, we use f of x or whatever the function is. If you just write x is greater than or equal to 0, you won't get any marks for your answer. Next up, we've got f of x equals e to the x. Again, we'll sketch the graph. Notice that the graph doesn't exist for negative values of y, and it also doesn't ever cross the axis, so it never reaches 0. As the values of x increase, the values of f of x increase as well, they go off to infinity. So as the output values have to strictly be positive, the range of the function is f of x is strictly bigger than 0. Next up, we've got f of x equals log x. Once again, we'll sketch the graph. For this particular function, it's important that we're careful to make the distinction between domain and range. When we were doing the domain, we noticed that the values of x had to strictly be bigger than 0. But let's look at the y values. If we choose x values bigger than 1, we can actually get any positive value of y out. This graph will increase up to infinity. Notice if we start with an x value of 1 and then get smaller and approach 0, the y values go off to negative infinity. That means the output of this function is any real number, and so the range is f of x is in R. Finally, we'll look at our fraction from the last example. We know that the domain is x equals minus 4/3. To find the range, it may be helpful for us to look at the graph of this function. So if we plot our graph on a graphical calculator, we get this. Notice that the shape of this graph is similar to the graph of a over x that we'd previously seen. It's not quite the same, it's in different quadrants and it's reflected, but we can see that it has the same kind of shape where it tends to infinity in the x and y directions. Notice that we could put a vertical asymptote in here. There is a certain x value that we can't get. We know what that value is because we previously found the range. It's minus 4/3. Let's add that to the diagram. To find the range of the function, notice that we could draw a horizontal asymptote across here, which means there's a y value that we can't get. In order to find that value, what we're going to do is consider what happens as the x values approach infinity, because they're going to get closer and closer to this asymptote, but they'll never actually reach. So what I can do is think about what happens as x approaches infinity. Before we do that, let's just think about what happens as we make the values of x bigger and bigger. If I was to put 1000 in here, I would get 2001 over 3004. As a decimal, we get this. But there's no limit on how big we can make x. If we make x, say, 1,000,000, we get 2,000,001 over 3,000,004. The thing that I want you to notice here is that the bigger we make x, the less significant the +1 and the +4 become. And so essentially, if we make x suitably large, the +1 and the +4 will make so little difference to the answer, we can basically ignore them. That gives us 2x over 3x. And the x's will then cancel to give 2/3. So f of x approaches 2/3. But remember, when we were looking at the graph a moment ago, we said that the curve will never actually reach this value of 2/3. So we can never get an output that's 2/3. And that means the range of our function is f of x is not equal to 2/3. Okay, to finish off this section then, here are a few quick fire questions for you to have a go at. Pause the video and then come back and check your solutions against mine. Welcome back. In this first one then, we've got a square root. Square roots only have outputs of 0 or above, but then we're adding 2 to that. So 2 plus a number that's 0 or above, the minimum value we can get out is 2. And so the range therefore is f of x is bigger than or equal to 2. Next up, we've got f of x is log 3x minus 1. Although we can only put positive values into a log, we can get any output that we want. So the range of log 3x minus 1 is f of x is a real number. For f of x equals sine x, a quick sketch of the graph will show you can only get outputs between -1 and 1. So the range is -1 is less than or equal to f of x, which is less than or equal to 1. For the next one, f of x is 3x over 5x plus 1. Consider what happens when x approaches infinity. The -1 will become irrelevant. We can then cancel the x's. We get an asymptote at y equals 3/5. So our answer is f of x is not equal to 3/5. For the final one here, we've got e to the 2x plus 1. We know that exponentials have to be bigger than 0. And that means if we subtract 3, the range is any number that is bigger than -3. So f of x is bigger than -3. With all of these answers, be really careful to check the inequality and check whether it's a strict inequality or if it can equal that value